Today, the energy industry is faced with a trilemma, defined by really three simple concepts. One, that we need securable, affordable, and scalable energy for a growing planet. Two, that energy must be delivered, consumed, and converted in a more efficient way. And three, we need new energy, cleaner energy, to support not only the growth, but the retraction of fossil fuels, which today represent almost 83% of our source. Adjacent to those three challenges, energy is also going through a fairly extensive digital transformation. And it's important to know that in the energy industry, many of the assets were installed, commissioned, and had been operating before the dawn of digital. And so that makes transforming those assets even more complex. If you think of automotive and some of the other industries that may be out there, there's a much faster recycle of those products to retirement. That's also a challenge from a sustainability standpoint. But in energy, that challenge is to bring digital transformation and digital thread through assets that have been operating for a long time. But it also means the opportunity is quite large, especially for simulation. As we connect more and more of these assets together through IoT and increased number of sensors, we're now able to bring not just ideation simulation to the product development and discovery, but now simulation into the full life cycle of that product through things like digital twin and operable twins. It may be simpler for folks to think of energy in this way. We have fuels and sources of energy. We have conversion of that energy, whether that be heat or electricity or motion, and then we have consumption of that energy. Today, almost 60% of the energy sourced, converted, and consumed is wasted. If we look at the challenge of the Paris Accord, we need to take about 40% of the current consumption and footprint of CO2 out of our industry, not just the energy industry, but all industry. And to do that in the short term, the best play is to improve efficiencies. 30% of the world's CO2 man-made footprint comes from the conversion of many different sources, gas, oil, and so forth, into electricity and the efficiency in doing so. Today, of that 30% of footprint, about 45% of that is used just simply in electric motors. So today's electric motors, before massive electrification of the transport sector, are already contributing to about 15% of the total CO2 produced by man on planet. Any efficiencies, small in that space, in any of the space around motors, will directly impact by 1, 2, and 3% CO2. If we look at conversion of electricity just in gas turbines, and we can improve by 1% the efficiency of that conversion, we could improve the overall footprint of CO2 on the planet by roughly 2.5%. Those are staggering numbers. Ansys is pervasive across all those industries of sourcing, of conversion, and of consumption, and has the opportunity now with our customers to multiply the value of simulation beyond just improving the fuel efficiency, beyond simply improving the material usage, but now into reducing the CO2 footprint that those products, services, processes, and systems have on the planet's sustainability. That's what excites me about Ansys' role in sustainability. That's how we're going to face into the trilemma of the energy industry, and that's how tomorrow and today will get better with the application of simulation.